Oh, would you look at this? What is that?
Those are subwoofers.
What do you do with those?
We make loud music.
Really?
Yep.
Nice. Oh, what is that? Look at that. Oh my gosh. Would you look at this? What is that? Oh, it's like it's shiny.
Oh, that's the capacitor, and that's the amplifier.
Right.
Do you know what an amplifier is used for?
No, what is it used for? Just fill me in.
It's used to amplify the signal given off by the head unit, which is the music.
The head unit? What's the head unit?
That's your radio.
Oh, go figure. Look
So
at that.
basically-
Oh, would you look at that? Go on.
The amplifier amplifies the signal from this radio to the subwoofers back here, so that they can produce the really low tones that are harder to produce.
I'll go figure. I never would have thought. Looks like a box. Just a little surprise in a box right there.
So basically, Ohm's law applies directly to the amplifier.
Go figure. Look at that.
Because it's got current, it's got the voltage from the battery, and we're going to find the resistance.
How are we gonna do that?
How are we going to do that, Mr. Stephen Cronin?
We're gonna put some equations in and then solve for it. Yeah.
So, do you know the equation for Ohm's law?
Actually, I do not know what the equation is for Ohm's law. Does anybody know what the equation for Ohm's law is?
Would you look at that? Oh, just look at that! Nice and white with blue letters! Oh my God, look at that! Ah!
V does, in fact, equal IR.
Take it easy. After you get R, okay? It equals V over I, okay? That is how you get the equation, okay? Thank you.
Resistance is then solved for by substituting 12 in for voltage and 57 in for current.
The resistance of the amplifier is equal to 0.21 ohms.
Intensity is the rate at which energy flows through a unit area perpendicular to the direction of wave motion, okay?
Why'd you do this? Get to the good part. Equals power over 4 pi. Distance squared. Oh, that's a really good song. There she goes like that. Professor Stephen, what could that P be substituted for? IV. Ah, would you look at that? That's an I and that's a V. Ah, go figure, look at that.
Would you look at that?
After substituting in the equation the numbers that apply to the formula, this is what it looks like. The intensity is 0.079110688. Watt per meter squared. Yeah.
Speed of light. Yes. Times like turning college. Light.
Lambda equals 299,700,000 792,458, which is the speed of light, divided by 10, which is the hertz.
The wavelength is equal to 2,979,246 meters.
Third one, yeah.
Did you know? Did I know? Speed of a wave
No, rewind it.
equals frequency times.
We gotta get that. I'll tell you. There you go. Later, sir.
Did you know? Did you know? Did I know what I know? Speed of a wave equals frequency times X factor times the wavelength. Hold on one sec, I gotta get off the phone. Really? The more you know. For our intensity equation, we did it 5 meters away. So the number that we got was 0.21. So that number is intensity of right here, right here. Because it is projected out 5 meters away. They may look like similar subs, they're actually quite different. This sub right here has an impedance of 4 ohms, also known as resistance. This sub right here also has an impedance, but it is not of 4 ohms, it is of 2 ohms. So together, this one is significantly louder and drawing more power from the amplifier. Therefore, this one is underpowered and not giving me a good quality sound. I should probably get that fixed. If you take a look, over here, you can see Derek subs, which are each an impedance of 4 ohms. Wired in parallel, this gives you an overall impedance of 2 ohms, providing the utmost power to both subs.